my 2 cents. My name is Paul, and I'll be giving you my 2 cents. I'm doing homework. I'm in program one at Fullsail University, and yeah, I'll be doing my homework. We'll get to find out if I finally received a grade for my classes, and I'll be headed to work this morning. So. So let's see. I take a program one at Fullsail. I have not received grades yet. Let's see if I finally received grades. No grades.
Alrighty, we should be ready to get started here. I gotta fix some stuff on my end real quick, and then alright, so let's go over here, and we start with our poll. probably a close second, right? Because concerned it just quality that I get. And so, alright. So what, if anything, from the previous lecture would you like to volume down over there? Stuff is quiet now. I don't trust that. A little bit longer. People are typing and then I'll do that over code. Switch statements. Easy enough. We can talk about both those in the same way. So here is our enumerator. The enumerator denotes something. What that something is could be whatever. Could be colors, could be math operators, could be HTTP status codes. Whatever it is, it's just associating something with a number. The number doesn't matter. We don't care about the number. We just need to know that if something comes up, if the something we're looking for comes up, that we can compare it to itself. Right? So, for example, if I'm trying to do a math operation, right? If I'm trying to do a math operation, I'm putting together the parts of my math operation. I'm going to say, okay, I'm going to make an int term 1 is equal to 4, int term 2 is equal to 6, and then math operator operation is going to be equal to math operator subtract. Right? Subtract has a number associated with it. I don't know what that number is. I don't care what that number is. That number has to be it's not important. All I need to know is that if I call a method that says like int do math, and I take in an int term 1, an int term 2, and a math operator, right? That I make sure that I do the right thing based on the math operator that was selected. Right? So for here, say okay, if, so we say int result is equal to 0. We say if operator is equal to double equal sign for comparison, not single equal sign. So double equal sign for comparison, math operator add, then I'm going to add term 1 and term 2. Right? As simple as that. a switch statement instead. So here, essentially math operator equal to this, or math operator is equal to this, or math operator is equal to this, etc. We can just do switch, pass in the math operator, and then say, okay, in the case that math operator is equal to math operator add, do this.
Good morning.
Otherwise, if it's math operator dot subtract, or math operator not subtract, math operator subtract, do this. So on and so forth. So it's the same thing as me doing if operator is equal to this, if operator is equal to this, except it's if operator is equal to this, if operator is equal to this, all the way down. We don't require you to do fall through or anything like that, so that other stuff that switches can do, I don't make you do, but I do show it to you in case you run into that issue, so you don't have break statements in the middle of each of your cases. Any other questions on any of this stuff?
So after math operator, you have add, subtract, all in all caps. Does it matter if it needs to be in all caps?
No, it just depends on how it's written in the numerator, right? And the pattern for something that cannot change, something that has a value that cannot be changed, is to write the name in all caps, so you have a reminder that it can't be changed. So I can't change, like, once the enumerator is made, I can't change the value of red. It is what it is. It's 0 here, right? It's never going to change. So I put it in all caps because that's just the pattern that I'm used to.
Okay, thank you, that makes sense.
Yep, no problem. Any other questions? All right. So today we are going to talk about looping and iteration, right? So there's going to be two primary types of loops we talk about. Like, there's going to be more than two loops, but there are going to be two types of loops that we talk about. So let me minimize this. Actually, no, let me move this down here. So the first type of loop that we will talk about is called an indeterminate loop. So like if you use a mobile phone, if you've used a cell phone in your life, you've seen one of two indicators. You've seen an indicator that looks like this, progress indicator looks like this, and a progress indicator that looks like this, right? So the progress indicator that is a progress bar, we call this a determinant. This has a known start and end. Goes from 0 to 100. So right now this one is at about like 8, right? So this is determinant. This has a clear start and end. This is an indeterminate. This will spin forever until something happens, right? So you get to the internet, and the page loads, whatever it is. We don't know how long it's going to take, but we're going to show you that something is happening until you actually get that thing, right? Any question about that so far? Okay. Next up, what we are going to do this is do the same thing over and over and over. That's it, right? So, at the end of the day, imagine we had an if statement, right? So if thing is true, right, then do thing, right? But not just do thing, right? Continue doing thing so long as thing is true, right? So if this is true, keep doing this thing. Does that make sense? So at the end of this, what it's going to do is it's going to go right back up here, and it's going to keep doing the whole thing over and over and over until thing is no longer true. So if you're looking at this now, understanding this as it is, one thing is clear, and that is that if thing does not change, this will happen forever, right? So that is what we call an infinite loop. If we are using one thing to determine whether or not we continue doing what we do, then that thing must be something that changes. Does that make sense? All right. So if that thing must change, and the only thing we're doing is the body of this loop, then this thing, the value of whatever this is, must change at some point inside of this loop. Keep that in mind. So let's look at the slide and see what that looks like. If we want to think of this in terms of our reference game too, by the way, think about what happens during your average JRPG battle or your Pokemon battle, right? What happens is each player goes back and forth forever until one of them has no Pokemon with no health, right? So that's literally the logic we will use if we get to the battle part. That's the kind of thing that we're talking about here. The syntax that makes it repeat itself, Brendan, is just making sure you open the construct with the right word. So if we make a loop, it should continue. At least this particular type of loop. There's going to be another loop that I'll show you as well. So iteration just means we do the same thing over and over and over. Iterate. In programming, that can be described as a few things. The first thing is just doing one thing repetitively. So doing one thing until we're done, right? Keep trying to load the page until the page loads. Keep trying to reconnect to the internet until the internet reconnects. Keep going back and forth between player turns until one player has no more Pokemon with health, right? Those are indefinite iterations, right? Perform an operation, check to see if we got the result we were looking for. If we didn't, do it again. Keep doing that, right? The other thing we're going to do is we're going to do counting. That is, doing something for a specific amount of times, right? So for example, if I have a menu, we saw a lot of menus, right? And there are 5 things on that menu. There will only ever be 5 things on that menu. It just says print the menu items 5 times. So 1, 2, 3, 4, 5. Those are our 5 menu items, right? Because printing those menu items is going to be the same every single time. So just do that 5 times. Done. Any question about that? Does that make sense? All right, cool. So to do this, we use what's known as loops. So we're going to talk about 2.5 different loops. Really, in any other language, it would be three completely different loops. But we're going to talk about 2.5 different loops. One of them we are not going to talk about today. One of them we are going to save for Friday, because it works kind of in conjunction with collections. But the 2 loops we're going to talk about today, the first one is going to be while loop. So a while loop is what I described before. A while loop is the same thing as an if statement, right? It will just continue so long as the condition is true. So whereas an if statement is a one and done, this is a forever, unless the condition is changed. So here you go. So here is a while loop. So here it is. Now 2 things must be true for a while loop, right? Number 1, if we are going to use a while loop, this condition, whatever determines that condition, must be defined before the while loop is created. Otherwise, the while loop can't use it, right? So in this case, we have a condition variable, whatever it might be, right? We must have a condition variable defined in order to use it for this condition here. Number 2, at some point within the execution of the loop, that condition variable, the value in it, should change. If it does not change, the loop will go forever. Any questions about that? All right. So, here's a basic example of what a while loop would look like. This says we're going to start an integer variable called number with a value of 0. And then it says while number is less than 20. And then in the body, it says number plus plus. So plus plus here is the increment operator. So what this will do is this will increment the value stored in the number variable by 1. So, if we read this literally, right, we make our integer number 1, or number 0, we check to see if 0 is less than 20, which it is, we add 1 to 0, which is 1, and then we come right back up here. So we go right back up here. Now, number stores the value of 1. Is 1 less than 20? Sure is. Add 1 to that, 2. Is 2 less than 20? Yep. Keep going all the way until 20. So once this is equal to 20, 20 is no longer less than 20. So then we are going to run the next line. So, like I said, we establish the variable inside, we update the value, we establish the variable outside, we update the variable inside. Any questions about that? All right. This will increase it by 3 every time, right? Which means now it's going to go all the way up to 21, all right? So it'll go to 18, then it'll go to 21. 21 is not less than 20. It'll break out of the loop. So let's take this and let's do some work with it, right? Let's give this descriptive values, right? They're descriptive variables. All right, so here's what we're going to do. We have a bucket. This is a 5-gallon bucket. Right? I would like to add an amount of water to the bucket every time. All right? So there was going to be an amount of water that's added to this bucket all the time. Right? Now, I do not want to fill the bucket up so much that it tips over, right? I only want to fill this bucket up until it reaches the very top. That's it. All right? So let's give ourselves some descriptive variables. So here we go. These are variables that make a little bit more sense. Current level is 0, and we are going to pour 3 into this bucket every time up until it reaches 20, whatever that is, right? So, using the logic that we have, can anybody figure out how to do this? Think about it for a second. Every single time that this loop runs, we are going to need to add 3 to this, which inevitably, it will eventually have 18 in it, right? Just 18 is a factor of 3. And when we try to add 3 again, it's going to hit 21 and spill over, right? Now, before we move on, this is the type of question that your labs are going to have, right? This is the kind of question you guys are going to have to answer for yourself. You guys know everything you need to do at this point in order to figure that out, okay? So there's a few different things you're going to have to do. There's a few different steps here, right? So think about that for a second. So we know, right, that if we continue going at the way that we're going, we are going to have that overflow. We don't want that. That means that if we add 3 to current value, and 3 is greater than 20, we don't want to add 3. That's not me talking in code, that's just me talking out loud. We could derive code from that, but that's the point where we're at right now. All right, so if we don't want to add 3 to 20, because that will make it flow over, how much do we want to add?
0.
We want to add 2. That makes sense. But you know what also makes sense? If we take 20 and we subtract how much is already in there, right? So 18, we will always get the difference of what it takes to fill up the level, right? So if we take the capacity and we subtract the current level, that'll give us how much space is left. So if we have enough room to add however much we're adding, we're going to add all of it. But if adding to the current level is going to be more than we can hold, then we take how much we can hold, subtract the current level, and that'll bring us all the way up to the top. Does that make sense? That is just me problem solving. That is just me working stuff out based on my understanding of the world, right? So here's what that code looks like. So if we isolate that, so it will do this chunk repetitively, right? So it says, okay, if we add 3 to the current level, which is how much we're trying to add, right? At this particular time, we're trying to add 3. And that brings it equal to or less than 20, which is our current capacity. So if it's either going to bring it up to capacity or less than capacity, then we know we're safe to add it, right? But if it won't be, the only other option it could be is greater than, right? So if it's greater than, then we are going to take the total, like I said, and subtract the current level, which will give us the difference. That's literally the difference, right? It's what we call subtraction anyway. So we can give this some more descriptive variables, right? And there you go. So this in particular is a lot of words, right? But this is the kind of thing, this is like what your code is going to look like for Lab 5, right? This is handedly the most complicated thing we have looked at so far. There is if statements in here and a loop. But again, nothing you guys couldn't do right now. Nothing like you guys should understand how an if statement works. You should understand the basics of how while loop works, right? Because nobody said they didn't, right? But this is what you're working towards, right? This is your goal. So is there any questions about any of this so far? I know there's a lot of words here, a lot of moving parts going on. So I want to make sure we take some time to break this down. Now, a common thing that's going to come up is everybody says, okay, that looks good, that makes sense there, but what about if I'm working inside of a test method? Well, here you go. It looks similar to this. Now, let me see if I can do something real quick. Yeah, Tony, it definitely can get confusing, and that's why, like, you have to, you gotta break things down piece by piece, right? You gotta, these aren't gonna be the same colors, but we're just gonna make these here. You have to break it down piece by piece. You have to do it one step at a time. So you saw how I broke that down, right? I said, like, okay, we know this, right? We know we have to do this. We know we have to do this. We know we have to do this. And I do those things one step at a time. When you guys watch me do it here, when you guys see it here, I get to the answer, right? Because I know my answer is correct because I've done this 100 times. You might try something, you guys might have an idea, run through it, implement all your code correctly, and not arrive at the right answer, right? Because you're still trying to work out the answer. And again, that's part of the process. From there, you use the information that you have, right? You say, okay, well, this worked and this didn't work. What can I change? Can I change like one of my variables and see if it's, can I change one of my variables and see if it makes a difference and what difference it makes and how it reacts and stuff like that. And you kind of go back and forth, like, you do some science kind of stuff with it. But yeah, that is the type of process. Again, nobody expects you to sit down at these labs, read the instructions, and just type out working code. That's not how this works. I made a video for somebody else yesterday, but it's the idea of like, all right, Have you seen the, hold on. Hold on, this is very apt. Why can't I unfull screen this? Oh. This guy. Right? Well, without my thing on top of it. Right? This is what a lot of people sit down in this lab and try to do. They say like, okay, I give you instructions, finish the owl. And there you go. That's not how this is gonna work. I am asking you to finish the owl, right? But I'm also showing you how to draw the individual parts of the owl first. I'm not showing you how to draw an owl, but I am showing you how to draw eyes and a beak and a feather. And you have to draw, this is one of the things I learned in computer animation, right? Is like, people want to make a photorealistic 3D model, right? You want to make a photorealistic 3D model of a person, right? So, okay, you want to make a photorealistic 3D model of a person, so you take a picture of a person, you start blocking it out, right? And they say, absolutely not. That is not how to make a photorealistic 3D model of a person. First of all, you've never made a model of a person. Second of all, you're overcomplicating it. First thing you need to do is take a picture of somebody's finger and make a photorealistic model of a finger. If you cannot make a photorealistic model of a finger, you cannot make a photorealistic model of a person. A person's got 10 fingers, right? So if you do not know how an if statement works, you are not going to understand how to solve a problem that needs an if statement. So you have to do if statements over and over and over until it's baked into your brain. That's muscle memory. You have to practice with while loops over and over and over until that's baked in your head. Do a while loop going forward, do a while loop going backwards, do a while loop that says, okay, if the user enters in A, then we're going to break out of the loop. But if the user doesn't enter in A, we're going to continue asking them to enter in A, right? Keep going, keep going, keep going. Then you do the lab. Does that make sense? I'm giving you guys the knowledge of what to practice. It's your guys' job to practice before you try to take the test. All right. So, here's how while loops are typically used, right? So that's an example of how we could use a while loop. Here's how a while loop is typically used. There's a lot of code here again. Nothing you guys haven't seen, right? So, while loops are generally used to validate user input. You guys won't need to do validating user input for your lab. You will need to do validating user input for your practical. So let's take a look at it. So, a lot of stuff going on. Let's focus on what's going on inside of the loop, right? This says we're going to initialize a placeholder variable called with empty string. We are going to cout, enter a number between 1 and 10. And then we are going to prompt the user, give me a number between 1 and 10. So ideally, right, they enter in a valid number. We're not going to assume they're not going to give us a valid number. And that number is between 1 and 10. So then we take in that number as a string, and we convert it to a number using S2I. Any questions about this so far? This is lab 2. Lab 1 and 2. Cool, so we have a number, it's an integer. If number, the number they entered, is less than or equal to 1, is less than or equal to 1, and number is less than, or so it's greater than 1, greater than or equal to 1, and it's less than or less than and equal to 10, right? So it's pretty much that says if it's between 1 and 10. There's several different ways to check that condition, which is why my brain is like trying to verbalize the wrong way. But so if it is between 1 and 10, we have an invalid variable, and we're going to say this is not invalid. We're going to set invalid to false, and then we're good. But if it's not between 1 and 10, if it's less than 1 or greater than 10, which is another way we could have checked this condition, right? Then we are going to say this is invalid, and we're going to keep looping. Now, in this particular demonstration, by default, I already set that value of that invalid variable to true. You can kind of see it's dimmed out up here, right? Because that way, first of all, the loop runs continuously right off the get-go. And number two, it reads like human readable. So while input is invalid, we keep asking them this question. So if they do not enter a number between 1 and 10, this whole thing starts over. We prompt them again, enter a number between 1 and 10. 5. Cool, breakout. 12. Enter a number between 1 and 10. Any questions about that? All right. Here's some comments. People ask me how much their code should be commented. That's about what I would look for. This is not how much I comment my code regularly. Right? So we initialize our placeholder variable while the input is invalid. Initialize the placeholder for the user input. Ask the user for some inputs as a string. Use S2I to convert that string to an int. Check the int is within the particular range. If at this point the int is still invalid, repeat it. Done. All right. Now, one thing about this, right? We're looking at this code. This makes sense. This reads well, but this bit of code should probably run first, right? Like, I'm checking to see whether or not it's valid before I even ask them anything, right? So it makes more sense that we ask them something and then check it was valid, right? Rather than just assuming it's invalid right off the get-go. So it'd make more sense if we had this while check at the end instead of the beginning. Because we want to prompt it at least once before we even bother checking. And this is a separate loop called a do-while loop. So it's the same thing, except it executes the body first and checks the condition at the end. So here's what it looks like. It doesn't quite look like an if statement, but it does look like, a while loop still, just with the while at the end. Full disclosure, whenever I do a loop in this class, it's going to be a do-while loop, like a while loop. It's going to be a do-while loop, because always I'm going to want to do the thing first before checking it. It's slightly more efficient, which is why we would use this over a while loop, but at the end of the day, it does not really matter. Any questions about this so far? All right. So it is 1:50. We're going to take our first break because we're getting ready to go to our second loop, and I think this is a good stopping point. We're going to say it's 1:55. We're going to come back here at 2:10 because we're like 1:52. So we're going to say come back here at 2:10, and then we will talk about for loops, which are actually not only the most common loop that you guys will see, but probably the most common line of code I've ever written in every language, bar none, because it doesn't change. So I will see you guys in a little bit. Alrighty, so we have talked about our indeterminate loops. That means this loop will go for as long as it needs to go, right? So this is our indeterminate loop. Some things we must remember, again, about while loops. If we're going to check a condition, the variable must be made beforehand, and the value must be changed inside. All right? We're all clear on that. All right. Since this is a very common pattern in loops, while loops are the oldest loops we've ever had. Like, while loops are the original loop. But since this was a common pattern, they created a new loop, quote unquote newer loop, that integrates both the initialization of this value ahead of time and the update of this value ahead of time. And that is the for loop. So the for loop has all of those things built in, right? So inside of the for loop, you will initialize the value that you're going to start with. You will do the check of the condition that determines whether the loop should run. And after the loop runs, you will update that value, and then you'll do the whole thing again, right? So this will do all of those things you need to do. So looking at the first example we had of our while loop, right? Here is a similar loop. So the first thing we do is we initialize a variable with a value. Then we check that value as our condition to determine if this loop should run. Then we run the loop, and then we update the value. Then we come back to the condition again and determine if the loop should run another time, right? So it's the same thing, it's just all built in. So if we're really looking at the steps, right? It's like 1, 2, 3, 4, and then 5, and then this would be 6, and this would be 7, right? So it runs like that. Any questions about that so far? All right. So, for loops themselves are exclusively used for counting, right? For the while loop, we could check inside of that condition if something was true or false. So like, if the user input was invalid, we set a Boolean variable, we have the while loop. But for loops are always a counter. Now what that counter looks like might be different, right? The start point, the end point, and how much we're going to increase by every time. But every time a for loop runs, it will be a counter. So here, you can see the for loop starts at 0. It ends, or it runs so long as it's less than 5. So it ends at less than 5, and it increases by 1 every time. And each time it runs, it outputs to the console, so it'll go 0, 1, 2, 3, 4, and then it will end. Any questions about that? Cool. Yes, every time it must have all 3. It will always have a start, an end, and an update. So this is like where it starts, where it ends, and how frequently it runs. All right, so here's a slightly different variation on a for loop. Same thing, except here we start at 1, we count up to 11, or we count up to less than 11, not 11. This is not inclusive, right? So it's not less than or equals to, it's less than, so less than 11. And we count by 2 every time. So this will only count out odd numbers. So it would be 1, 3, 5, 7, so on and so forth. And then this one is a way we could check for even numbers. Now we could have done it the same way. We could have started it at 0 and counted by 2. Or we could start it at 0 and modulo. So this is a very common pattern. This is something that you guys will use a few times. But if you want to check to see if a number is even, you say modulo 2. So if I have 10 modulo 2, then it can be divided evenly without a remainder, so this is equal to 0. In the same vein, 10 modulo 5 is also equal to 0, right? So instead, like, also 15 modulo 5. So if it is a factor of something, like if it's a clean divide, modulo will equal 0. So the most common way to use it modulo is still for even numbers, but you can also use it for all these other circumstances. And you will need to do that. We can also count backwards. Again, it's a rare thing that we need to do, but we can count backwards. So this would start at 10, and it would count down to 0, right? So it'd be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It wouldn't do 0 because it's not an inclusive loop, so it's not less than or greater than equals to, it's greater than, so it's only while it's greater than. And it's subtract means we're gonna decrease. So plus plus means increase, minus minus means decrease. So this will decrease it by 1 every time. But it's the same loop otherwise. And here's an example of start and an end, right? So we have a start variable, end variable, and just to make it easier, we can syntax highlight it, and that's an example of what it might look like in a method, right? But that right there, that is the whole crux. That is the whole use of a for loop. It will always be the same. Now, at the end of the last section of the lecture, I said for loops are probably my most commonly written thing in all programming, right? That's because for loops never change. So whatever language you're in, for loops pretty much look almost exactly the same. And they will almost always look like this. So if you look up how to do a for loop in any language, right, it's gonna look the same. So if you're struggling with for loops, you can just look up for loops in general, and the internet will provide, right? But they will typically look like this. So for int I is equal to 0, while I is less than a number, I plus plus. That is the most common for loop you will see anywhere. I here, generally we avoid single variable names, right? Generally we avoid single variable names. I here is kind of an exception. We use this because, number one, for loops existed in a time where we had small screen resolutions and you can only fit in 80 characters. So they used single name variables back then. But number two, I here is doing double duty, right? I is known as our iterator, right? So it's known as our iterator, which is basically our counter, right? It keeps track of how many times our loop has run. But also, when we are dealing with collections, this is a preview of Friday, it also corresponds with the index of the collection that we are observing. So, like I said, we're gonna jump ahead a little bit here, right? But when you guys were taking discrete math, which I know you guys all paid attention to intently, because even though it's a multiple choice, multiple attempt class, you understood the importance of those things and why it came before your programming class, and you have notes and you can go back and look at it. But in discrete math, we avoid single variable names because they're not descriptive. We want to make our code human readable, so single variable names are not descriptive at all. So in that class, they talked about sets. So you'd have a set that looks like this and has numbers in it, right? So this is the equivalent of a set in discrete math. Now, each one of these numbers, a set is a collection. It's a collection of numbers. Each one of these numbers is known as an element, right? And each one of these positions is known as an index, right? Well, index, yeah. So each one of these elements is stored as at an index in the set. So if we want to list every single element in our collection, right, we access them via their index. In programming, it's going to start at 0. So this is 0, 1, and 2. So for example, if I said, instead of 10 here, I said 3, we always stop counting at 0. It would do 0, 1, 2. It would list each one of these out. It would go 1, 2, 3. And then when we get to 3, right, so if we went to 3, which would be out of the bounds of the available collection, 3 would be less than, or would be not be less than 3. 3 is equal to 3, so it wouldn't run. So we're going to come back to this. There's going to be a recurring theme for the next lecture on Friday, but keep that in mind, right? The I here is both iterator and index, because it will correspond with the index of elements and collection. You probably have questions about that. Don't worry, save them for Friday. I'm not going to make you do that right now. Alright, so, what loop do we use? How do we know what loop to use? Well, number one, does it need to run a specific amount of times? Remember, we have indefinite loops, we have definitive loops and indefinitive loops, right? If it does not need to run a specific number of times, if it just needs to run as many times as it needs to run until it's done, that will always be a while loop, right? So, if it just needs to run forever until something is met, while loop. If it does need to run a specific number of times, are you looping through a collection? So a collection is a set, right? If you are looping through a set, if you're not looping through a set, then you're going to use a for loop every time. If you just need to go a specific number of times, then you are going to just use a for loop. So if you just need to, I need to loop 5 times, for loop is on, there you go. If you are looping through a collection, is the position important? Do we need to keep track of where something is inside of the loop, right? Like, if we are looking for a specific thing and we need to know where it is, the for loop will help us here because the for loop keeps track of the counter. So if we start at 1 or start at 0, did we find the thing we're looking for? No. Did we go to index 1? Did we find the thing we're looking for? No. Index 2, did we find the thing we're looking for? Yes. Now we know the thing we're looking for is at index 2. Also stop looking because we found the thing we're looking for, right? So the for loop will allow us to not only search for something, but also keep track of where it is. Otherwise, we would use a different loop, which is known as a for each loop, which we'll talk about when we talk about collections, right? So the for each loop will just indiscriminately list out everything inside of the collection, but you don't necessarily know where it is in the collection. That would be an important distinction. Alright, to review the keywords that we talked about today. These are the important keywords for dealing with a loop. Number 1, the while loop prefixes the condition of the beginning, while prefixes the condition of the beginning of a while loop, effectively replacing if to make this, to convert an if statement from a to a while statement. Do is going to usually prefix the entire body of a do while loop. For is going to be able to prefix the beginning of a for loop, but we also have our break keyword again. So remember, a break keyword will immediately exit out of a conditional statement, a control flow statement, right? So we can also use a breakpoint to break out of a loop. If you recall, moments ago, I said, if I'm looking for a specific thing in a collection, once I find that thing, I should just stop looking. The break keyword will allow you to do that. You say, okay, I found the thing. I'm looking for number 5. I found number 5. I don't need to look anymore, right? You won't need to use it in lab 5, but you will need to use it eventually. Keep that in mind. So we have a number of operators. Mostly are comparison operators, but we also have increment and decrement. So this right here, yes, break will work with any control flow statement. It'll work with an if statement too, but that would be weird. But yeah, it'll work with any kind of loop. So this will increment the number stored in a value by 1. This will decrement a number stored in a value by 1. Greater than and less than will allow you to set ranges for your loop, but those loops will not be inclusive. It's a common pitfall for lab 5 for you to make your loop not inclusive when it needs to be inclusive. Keep that in mind. If the last number is a thing that needs to be included, you must do less than or equals to. If it's not, you can do greater than or less than. You will commonly see a loop written with less than, but that isn't an inclusive loop. That might not be the loop you need to do. So these will do equality as well. These will allow you to make an inclusive loop. And that is it. Any questions about this so far? Alrighty. Well, let's get into some coding. We're going to do a normal demonstration, and then at the end of this, we'll do our bigger project. next time. It must be somewhere weird. Yeah, there it is. Alright, we're gonna open up our solution. Well, did I do it empty? Oh man. Not what I wanted to do. I don't want to set all that stuff anyway. Okay, Visual Studio. And we already know when I make a new project, it's gonna make me close it and reopen it again. Console application. Real loops example. Okay, minimize this. Alright, cool. I'm gonna save it. It's not gonna work. Well, maybe it will work, but now I'm gonna try to save it. It won't work. So I'm gonna close it. I know, you don't like it. I'm gonna kill it. I'll reopen it. One day I'll figure out what that bug is, but updating to Windows 11 did not fix it. And we'll go to the real loops example. Yeah, my god. Two-factor everything all the time. Alright, cool. Alright, so let's test out our loops. First one's our while loop, right? So we're gonna say while true, literal value of true, we're gonna say std cout, we'll say int number is equal to 0. Say while true, number plus plus. We'll say this. We'll do while true, cout number space and number plus plus. This is going to be great. So I'm going to run this. And there we go. And that'll go for, until true is no longer true. So, everything is forever. So that is known as our infinite loop. That is just counting up. It'll either run until, we run out of memory, which probably won't happen. Or until true is no longer true. Yeah. Integer. Yeah, it'll probably run out when it hits the integer total, right? Maximum. So we should make it a unsigned long int. Yeah, so yeah, it'll probably overflow eventually and break. But yeah. So, first of all, yeah, it is kind of like the Matrix. So first of all, don't do that, right? So again, whatever this condition is, we need to change it. We need to, the condition we checked also needs to change here. So now we'll change this to, well, number is, I don't know, less than 10, right? And this is gonna happen so fast, we're not even gonna see it happen. Like, it's just gonna, it's like instant, right? So now we have 0 through 9. Boom, there we go. So what happened is, we started at 0, we wrote a number to the console, and then we increased the number. We can slow this down. Well, we can't slow this down, but we can slow the whole application down. So this is not something you guys will need to do, but I'm going to do it for demonstration purposes to make stuff easier to visualize. But computers these days, nowadays, we have what's known as a multi-thread computer. Which means a computer can do multiple simultaneous operations at once, right? Our application runs on a single thread right now. We're a single threaded application, which means we can do one operation at a time. We could add more threads if we wanted to. We're not going to need to. So we do one thing at a time. So one way to make this a little easier to visualize is we can slow down the execution of that thread, right? I got to do a lot of things in here, but I got to do the most important one is include thread, so we can control threads, and I need to include chrono, so I can control time. So then I'm going to do std. This thread sleep for std chrono milliseconds 20. Nope, I missed something. This whole thing won't work until I actually get it right. Maybe it's not STD, maybe it's just chrono milliseconds. Maybe it's just milliseconds. I don't remember exactly. This is right. This looks right. This thread sleep for. All right, hold on. Nope, I seem to be right. Yeah, you know what? It's SD chrono millisecond. Right? No? No, it is millisecond. This thread, sleep for std chrono seconds. Let's try seconds. No, I'm missing something here. No, it's chrono seconds. Oh, it's chrono in chrono seconds. Okay, yeah. Okay, so this will pause the execution of our application for 20 milliseconds before running again. And again, you guys don't need to do this, but I'm going to do it because it makes things easier to read. All the labs between lab 2 and 8 will be very similar, but labs 4, 5, and 6 will have multiple steps. So lab 2, you had one step pretty much. Lab 3, you mostly had one step to each test, besides making your own method, right? And that's kind of 2 steps. But labs 4, 5, and 6 will have multiple steps to them. That's the big one. It's a main difference. All right, let's run this. Well, it's still really fast. I'm gonna make this 250 milliseconds, which is gonna be painfully slow, but now you can see it actually executing. There we go. So here's what we're gonna do. I'm gonna make a new method. It's gonna be called void sleep thread, and I'm just gonna put that in there. That way I don't have to type that out every time. So I'm just gonna say sleep thread, and that'll make my loops easier to see. All right, so that's our while loop. So now I'm gonna comment this out for now. We'll do our do while loop. So do while loop does the same thing. So it'll do the check afterwards. So like I said, it's common for us to use this for user input validation, right? So we're gonna do std string. I'm gonna say name is equal to an empty string, and we're gonna say std cout. What is your name? Question mark. Std end line, and then we will do std cout again. Name colon space no end line, and I will do get line std cin, and then store the name variable. We need to include string at the top. That's the thing we will need to do. And I'm gonna forget line to work, and there we go. Any questions about this part so far? Cool. All right. Yeah, I mean, it's I definitely yeah.
Oh, I think it's just a typo.
Being able to keep up is a chore. The challenge of this class in general, right? The challenge of this particular class is that I have 4 hours to show you guys as much as I can, and then on top of that, you have to do your own practice, right? Just a question. This is for the online people as well too. A show of hands. Has anybody ever attended a class at a traditional university? For me, the one I'm going to use most often, we can come here, std cout, and we can say hello, comma, space, name. And we can concatenate those together. So we could not be an hour long. I have 4 hours to show you guys as much as I can, and then on top of that, you have to do your own practice, right? Just a question. This is for the online people as well too. A show of hands. Has anybody ever attended a class at a traditional university? So you guys, anybody online? No, so we have like 3 people here. Okay, so at a traditional university, This lecture would be an hour long. I would show you the syntax of a for loop. There'd be 200 people in here, and I'd say, all right, go. Like, that's the whole thing, right? So I'm trying to do more than that, but I'm also like, you know, this is an accelerated program. We are fitting a whole 3 months of programming into today, so it is. But yeah, if you need me to stop, you need me to slow down. You have a question. You're not grasping something. If you don't fully understand everything, let me know. But a lot of the stuff will just take practice. All right. Well, there's a question. Get line gets the whole line. Yes. Whole line will get the whole line. If you were to like C in, and I were to like put Doug space Arlie, it would only grab the first bit. It would break it at that. In addition to that, if I pressed Enter, so it ignores white space characters, right? If I were to type in enter, so if I were to get prompted and just type in enter, it would ignore that. And it would just hit enter forever. I can show you an example of what that looks like. Hold on. So we run this. Oh, I didn't even do the prompt, so hold on. Other way. No, when I mean traditional, I mean like the community college, major university, a non-accelerated school. Like this is an accelerated school, we get everything done in a month, right? Right, so this is what CN does. I can press enter all I want, and it's not going to do anything until I type something in. And then it ends. And it would only capture Doug instead of Doug Arlie. So get line gets the entire line, including any empty spaces. So if I press enter, it'll just exit, which is going to be important for this particular demonstration.